respected Dean, END, Dr. N.G.R. sir. I welcome you, sir. I would like to welcome all our executives and heads of the department of our university and colleagues. Last but not least, I welcome our department faculty members and delegates from various institutions. Department is indeed happy to have you all together for joining this FDP, and a big thanks to each and everyone present here. The department feels privileged and honored to have the fullest support from our Honorable President, Engineer A.C. Kumar sir, Vice Chancellor Madam, Registrar, and all other office bearers. 3D printing today FDP is 3D printing and or additive manufacturing is the construction of a three-dimensional object from a CAD model or a digital 3D model. It can be done in a variety of processes in which material is deposited, joined or solidified under computer control, with the material being added together such as plastics, liquids or powder grinds being fused, typically layer by layer. 3D printers are versatile and can produce complex or customized products. Additive manufacturing offers innovations, process improvements, and greater ability to many industries, including aerospace, dental, medical, and automotive and space propulsion, satellite parts, rocket engines, and more. Now, I request all the participants to gain the knowledge on the next 5 days on FDP on additive manufacturing and make use of it. Now, I request VC Madam to give inaugural letters. Thank you.
Very good morning. Hello. There is an echo going on. Very good morning to one and all.
Good morning, madam.
And on this occasion of the Department of Mechanical Engineering, in the presence of the HOD, Mr. Rajan, and the Dean, Etiraju, it's really, and his team, to make this possible today on the FDP program on the latest trends in the additive processing and manufacturing. This is in collaboration with the Association of Academic Staff College, the 5-day virtual faculty development program. In fact, I should thank the management for giving the Department of Mechanical the opportunity of conducting this FDP program, and also thank the department for making the other faculty to get trained in it. So, as you say that, in fact, I have a liking for this 3D printing and all these additives, because in the medical field we have this 3D models or anything which requires a prior surgery or prior the students have to see. They have to see this 3D kind of any organ or any kind of surgery to be done. But sometimes they are they are hard, but I had wanted a soft one so that anything can be made as a real one. So it is a pleasure to speak to you with these above exciting field of additive manufacturing, commonly known as 3D printing, which we have. And I've seen in many of the universities this 3D printing with the mechanical, they have utilized it for various purposes. So I want the department to use it for the various interacting with many other departments, particularly medical and other departments which want to have a prototype of their research product. So this transformative technology is revolutioning industries by enabling the creation of complex and customized products through layer by layer material deposition process. So in this medical field, I think the 3D printing is being used to create custom implant, prosthetics, and even bioprinted tissues, enhancing patients' care and outcomes. In aerospace and automotive industries, it facilitates the production of lightweight, high-performance components. Additionally, the ability to quickly and make it possible and produce parts on demand in streamlining products development and reducing the time in the market and also in the research design. As we continue to innovate and refine the technology, the potential application of additive manufacturing will only keep on expanding bringing even greater efficiencies and possibilities in manufacturing processes. So this conclave of additive manufacturing is not just a technological advancement, it is a catalyst for change, and it is a driving to innovation and enabling new levels of customization and efficacy. I'm really excited to see how this technology will continue to evolve and shape our future in all the endeavors. Thank you, one and all, for making me to come to this program. And I love to listen to you all in the 5-day program. Thank you, and all will benefit out of it. Thank you.
Thank you very much, ma'am, for your inspirational message. So I will now request Dr. D. Vishwanathan, Honorable Rector Sir, to come forward and give his special address on this case. Rector Sir.
Good morning to all. Beloved
Good morning, sir.
President of Dr.M.G.R. Educational Research Institute, Engineer A.C. Saran Kumar, respected Vice Chancellor Dr. S. Geeta Lakshmi, distinguished speaker from CAD Center, Mr. Lane Mohan, respected Dean Etiraj, Professor Rajan, respected Professor Pallivari Registrar, distinguished faculties, respected participants, ladies and gentlemen. I am extremely delighted to join with all of you in this FDP program. At the outset, I would like to congratulate the Department of Mechanical Engineering faculties for organizing this FDP program. It is one of the emerging field picking up in the field of mechanical engineering. It's a very good effort being brought by the head of the Department of Mechanical Engineering, getting a full awareness about the applications of 3D printing. In fact, recently when I visited the DRDL, Hyderabad, I could see the additive manufacturing, metal manufacturing system, which is one of the latest and biggest 3D printer in our country. It is being used for the manufacturing of missile components and rocket components. So that way, the starting era of 3D printing and rapid prototyping. Previously, before additive manufacturing, it was called as a rapid prototyping. They established the parameters of mechanical prototyping as a special method class for boosting the most necessary stages of product development with a fast and accurate process of building objects that takes into consideration various emphasis of an item to show up more rapidly and productively at an ideal product development system. This sets aside time and cash at the start of the whole item advancement process and guarantees certainly in front of creation tooling. Prototyping is still a big, sometimes overlooked application of 3D printing today. Since the advantage of additive prototyping, the consequences and improvements of process and material have been taking the product development process chain further downstream for applications. Tooling and casting applications have been developed using the advantages of different processes. Again, these applications are increasingly used in the industrial sector. Similarly, for final production operations, efforts continue to improve. As for the industrial revolution, and global markets are moving towards the industrial 3D printing techniques for a lot of applications like dental, jewelry, architecture, medical consumers, fashion, aerospace, tooling, food, automotive, etc. There is an increasing use of composite materials, including carbon fiber reinforced polymers, which provide higher strength to weight ratios. New alloys and metal powders are being developed, expanding the applications of metal 3D printing in aerospace, automotive, and healthcare sectors. Innovations in biocompatible materials are facilitating the printing of tissues and organs of medical applications. The ability to print with multiple materials simultaneously is becoming more refined. This allows for the creation of complex objects with varied properties such as combining rigid and flexible materials in a single point. Technologies like a continuous liquid interface production, CLIP, and advancements in stereolithography are significantly reducing printing times. Industrial 3D printers are now capable of printing large objects, including parts of aerospace and automotive industries, with a higher precision and faster production times. Automation in post-processing, such as cleaning, curing, and finishing printed parts, is improving. This reduces labor costs and increases the consistency and quality of finished products. Enhanced design software tools are enabling more complex and optimized designs for 3D printing. The use of digital twins, that's virtual replicas of physical objects, is gaining traction, enabling real-time monitoring and optimization of the printing process and the end use performance of printed parts. Development of recyclable and biodegradable materials is becoming a priority to reduce the environmental impact of additive manufacturing. Additive manufacturing inherently produces less waste compared to traditional subtractive manufacturing, but innovations are further minimizing material waste during the printing process. Combining additive and subtractive manufacturing process, such as CNC machining, is in a single system allows for the production of parts with complex geometry and high precision surfaces. Customized medical devices, implants, and prosthetics tailored to individual patients are becoming more common. Advances in bioprinting are paving the way for creating functional tissues and organs, which has significant implications for regenerative medicine and transplantation. As additive manufacturing becomes more mainstream, there is a push towards establishing industry standards and regulatory frameworks to ensure the quality and safety of 3D printed products, especially in critical fields like aerospace and healthcare. Connecting 3D printers with the Internet of Things, IoT, enables real-time monitoring and control, improving efficiency and reducing downtime. AI and machine learning are being used to optimize print parameters, predict failures, and enhance the design process, leading to higher quality prints and more efficient production workflows. The concept of distributed manufacturing, where production is decentralized and carried out close to the point of need using 3D printers, is gaining traction. This trend is particularly relevant for shape parts production and rapid prototyping. In conclusion, these trends highlight the dynamic and rapidly evolving nature of additive manufacturing, driving innovation across various industries and transforming traditional manufacturing paradigms. With these few words, I wish the FDP a grand success and congratulations again to all the faculty who organized this program. Thank you very much.
Thank you very much, sir. It's been an inspirational and a learning experience for us. Now, I would like to request Dr. N. Ethraj, Dean ENT, to come forward and put forth his perspective on 3D printing. Sir.
Good morning, all of you present here. Respected Vice Chancellor, Dr. S. Geeta Lakshmi ma'am, Rector, Dr. Vishnu sir, HOD, Dr. Rajan sir, and all other faculty members, participants, students, executives, and other department HODs. See, actually, I first wish to congratulate the mechanical engineering department for selecting the proper title, especially now in production. Everybody started talking about additive manufacturing, and this has to make an awareness towards the additive manufacturing to all the people, irrespective of whether they are the student or the faculty or the public. See, additive manufacturing is also known as 3D printing or layered manufacturing or solid preforming method. And this is very useful in rapid prototyping because of its flexibility in design and manufacturing. And since there is a flexibility in design as well as manufacturing, it is very, very apt for implant manufacturing because you know that the implants are depending on the patient. You cannot make a standard one usually, what we do it for other components. So it is gaining a very wide acceptance in all the fields. And now people are working on polymers, metals, and composites. So it's very compatible with all the type of material, whatever we are using it for the nest. And one more thing is actually the list has been given, which is going to be the very prime area for the next 20 years. In that list, a lot of computer science areas are there, like AI, ML, data analytics. And as far as the mechanical is concerned, or we can't say that it is only restricted to mechanical, or other side of the computer science side, the additive manufacturing is one of the area which is going to flourish in the future. And there is a prediction that it will be occupying the additive manufacturing machine is going to be occupied in all the homes, like whatever you have in home, like TV or fridge. Only thing is, whatever material you want to process, according to that, you got to buy a machine and keep it in your home. And suppose you want to manufacture something, you have to buy only the program from the Amazon or some other person, like what you buy from, whatever buy from others. So you buy and get it, and according to your wish, you change and modify and print it and make your own component for your wish. This is what the prediction is. So almost in all the countries, it has come as a usual, what do you say, it is a roadside shops where whatever you want, you just go and say, this is what I want. They immediately make a design and then make a program and then print it and give it immediately. It's like fast food. So this is going to be the prediction, and massive expansion is going to take place in Amazon as well as in Wipro. They are trying to have all the components, only the code they want to get it from you according to your requirement. And based on the code, they'll send the program to you. So they are trying to develop the program for all the, for example, suppose if you have an automobile, for all the automobiles, they want to have it a program. So not only that, there are a lot of computer related fields which are interrelated to the additive manufacturing. For example, AR and VR, digital manufacturing. Now, recently I read an article on large language model. So LLM also, they started using it. So you have the fact, I request this students, suppose you want to enter into this field, you must know how to write the program and how to set the parameters based on the material what you are using. And especially a lot of challenges are there as far as the additive manufacturing is concerned. You have to solve one by one. And I request the faculty members to gain knowledge in the additive manufacturing and try to incorporate the advanced technology, so whatever is available as far as the computer field is concerned. Try to incorporate all those things in that. And once again, with that note, I congratulate the mechanical engineering department for organizing this FDP. And I hope that this FDP will be a grand success. Thank you.
Thank you very much, sir, for your eye-opening message. Now, I will request Dr. K.R. Vijaykumar, sir, to give the vote of thanks, sir.
Good morning, one and all present here. It gives me immense pleasure to deliver vote of thanks for this 5 days online FDP on latest trend in additive manufacturing. On behalf of Department of Mechanical Engineering, I am proud to extend my sincere thanks to Vice Chancellor Dr.M.G.R for her inaugural address. I also extend my sincere thanks to Rector Dr. D. Viswanathan for his special address. I express my sincere thanks to Dr. N. Yatiraj, Dean ENT, for his constant support and special address. I wish to express my deep sense of gratitude to Engineer A.C.S. Arun Kumar, President, for his constant support and encouragement to conduct such event. I would like to acknowledge our gratitude to Registrar Dr. C.B. Palanivel for his constant encouragement and support. I express my sincere thanks to our HOD for his constant support and encouragement to conduct this event. I also express my warm gratitude to all my colleagues for their continued support to make this event grand success. Last but not least, I thank all the participants for making this occasion a grand success. Thank you.
Thank you very much, sir, for your vote of thanks address. Now, without any further delay, I would like to invite Shri Ligen Mohan, sir, Manager, Technical CAD Center, to be the part of our resource session. Before requesting the sir to deliver his technical session, I would like to mention few words about his journey. Sir has been a corporate trainer with strong knowledge in automobile engineering, and he has got a distinguished work experience over various corporates like Vortex Engineers, Eban Informatics as a CAD specialist, and also he has been doing giving corporate training for Ashok Leland, for Eaton Corporation, Ford, Central Public Works Department, L&T, TCS, MRF, and Caresoft Global Private Limited. And he has also been a guest lecturer for NIFT, Chennai, National Institute of Technical Teachers Training and Research, NITTR, and Academic of Maritime Education and Training University, AMET. So, sir, the stage is now yours, sir, to come forward and share your expertise. Ligen Mohan, sir.
Hi, sir. Thank you so much, sir. I'm audible, sir? I'm audible? Or no?
Loud and clear, sir. You are very loud and
Okay.
clear.
Thank you, sir. Thank you. Thank you so much. And before that, whatever I want to introduce, you clearly explained about me, Nook and Corner. And the people who are coming here, they are very good knowledge about the overview knowledge about the 3D printing and what is additive manufacturing. And I'm impressed with Miss Geeta Lakshmi. Ma'am have a very good knowledge about, I think more than me, she knows well, theoretically. Yeah, we do already, we are in a practice, we are working with the 3D printers. We used to do the 3D printers for our own students as well as some projects also we are doing. And all the hierarchy people who are speaking today, so they are good in understanding about what is the 3D printing, why they are there.
Morgan's video is not appearing.
No, sir, actually, I'm just sharing that PPT, sir, so that makes sense. Sorry for that, sir. Yeah, and what I do is that, yeah, we giving that corporate trainings, and we're mainly focusing on the student to place to the company, because you know that after COVID there is a very lag in that. They are very good in modeling, and you can answer anything, but if you go for the basics of engineering drawing, they are very much lag in that. The companies is asking the people who are coming for the interview, they should know what is a basic, because the basic is what we are teaching in your institution or colleges, as well as we just go through that basics first, because when you go for a CAD or whatever, the software is a secondary. What they want is that how good you are in that basic of engineering. Can you understand? Can you able to read the drawing? So that is the first thing they are doing. They're checking, because we have a very good type with the tier 1 companies. So what they want is that we need a person to understand what they're going to do, like the reading the drawing. So we are just focusing mainly on that, how you should read the drawing, how to become a team player in the company. So they are the first thing they want. After that only we can, whatever the technology that they will teach, once again what we teach, again they also teach it on that. So we just want to place the person in a company. So that is the main focus of a CAD center. And further, before going for a 3D printing, I just want to share my PPT. So please check and tell me you can able to see my screen. Okay, so please, anyone, you can able to see my screen?
Yes, sir, you can see. Sir, you can zoom it, sir.
Yeah, this is okay, right?
Fine, sir.
Okay, fine. So additive manufacturing. So actually it's an overview. You know, this is a very vast subject. but it's very easy only. But it's very easy. What in a trend? Actually, that the trend should be start from 2020 because of a COVID is stretched to 2025. All the companies need a 3D printers. Previously, it's used for a prototyping. Now we can go for a working model directly. So that much advanced. And anyway, whatever that new technology is coming inside, there is a pros and cons will be there. So as per the pros and cons, I just go through with it so that you can understand clearly whatever making what you are talking that. I'm just going to show before additive manufacturing, what we are doing currently. Right, that is what legacy, what we are doing the manufacturing. I just go through that, then you can understand clearly what is additive manufacturing is going to do. For that, I just want to play a video, so it's clearly understandable. Uh, Whatever we thinking, we directly going. I mean, the people used to think that is whatever. No, they will just go for a 3D model in a modeling software, then it will go for manufacturing like that. No, there is not a complete scenario what is happening exactly. But whatever design is starting, start from paper and pencil. You just see this video so that you can get a clear understanding what can be done in additive manufacturing and that traditional manufacturing. Yes. So this is what the start from scratch. I hope you can able to hear my voice, right? Please, anyone?
Yes, sir. It is
Okay.
audible.
Thank you. Thank you. Thank you so much. See, we know that. Just a minute. Actually, what we saw is that from starting to end. So how to that concept model will start, the need. We understand the need, so that water bottle, you see, right? What are the parameters they're taking before going for that vast manufacturing or go for a mass manufacturing. So there is in fact, it is just a water bottle, right? So they are doing this much of effort to create something like this. If you go for very efficient, like it's using for a cars or aircraft and all, then it will be more care to be taken in that. So just what I say, trying to say in this video is that you can see that after the design, there is a more process in this. Once design is completed, then it will go for a molding. Before more, you have to design the mold also. So not only for the PET bottle, you have to go for that mold design. Then mold is expensive. So you have to create that design and you go for a molding. Then you have to, there is a lot of process when you're getting into that bottle, right? So just a second. Okay. So here, actually, as per this video, so it will be coming up to design. This is up to the design. They are using the designing tool called CATIA. Yeah, because of a European German country. So Europeans normally they go with CATIA. In fact, it's too expensive, but still they are trust on the softwares. And this is from cost model to design. After that, what happening? No, you can see the video. It will be go more than no, it will be stretching to more than 1 minute. But here it stops actually, right? So no need of going for the next stage. It just once we got the 3D model, till this what we need actually for additive manufacturing. You just think about that, no? It will take only if you take a video, it's a concept model and it is going for a 3D model. After this much lengthy is process how to get into the bottle as a real time. But here it comes when you go for a 3D model or additive manufacturing, once this model is ready, is satisfied with whatever that the constraints or parameters want to maintain in the particular bottle, then it will go for a manufacturing. Not a prototype. You can directly create or no, you can get output of a real bottle immediately. So you can see now it will take in too much of time as well as it will be very costly also. Right? Designing or creating of a mold and all, it will be more expensive. And there is no second choice. If you have any once mold is ready, then you have to do the same because there is no chance to do it again. And design is improved. And if you make a changes in that, again mold will not use because we already spent too much of money in a molding. So whatever is there, we just finalize, we go for that. But when you go for a 3D printing, if that output is not satisfied, we can generate another model. It will take, or what are the modification you can do it. It will not at all affect. Anyway, what I said is a pros and cons is there. That is when you go for a mass production, then there is a lag on the traditional way of manufacturing and what we are doing in the 3D printing. And what is additive manufacturing? A simple video for this also. Just a minute. Just a minute. Can you able to see my screen?
Yes, sir.
Can you able to see my screen?
Yes, sir. You can see.
Okay, fine. A small video. Yes, it's a good to go, right? So what is additive manufacturing is clearly explained. So there's a layer by layer concept. So we go for what is additive manufacturing. So converting 3D digital model to that actual physical model. So that's what we are trying to do. So what previously is doing the same thing. Till now, the people are always learning the 3D modeling software. The same, it's fine for them. After that, it go for direct print. And before printing, there is a small bridge between the 3D modeling software and the 3D printer, because we have to convert as a G code. So we need a coding for that. So for that, we need a slicer. But most interesting thing in this, no need of aware of 3D, I mean, that coding and all. If you know the coding, then well and good. So they seem like a CAD CAM coding only. But if you don't know the coding, no issues. There is a slices, the name called slices tool, that is a free of cost only. That is a software called slices. There is a Cura and all. Anyway, upcoming slides I show you. So that particular software will be sliced accordingly how many layers you want to slice the particular object. So why? Because of the 3D printing, you know, right? We are just print on, or no, you're just making drawing the same place again and again and again. So that will be create like a layer. The same thing is what we're going to do. So you have to tell the tool or a software how many layers you want to do, because no, some of the feature it will be outer is okay, because we need only the aesthetic surface. We don't want that B class. We only want a class. There's a top face or aesthetic face. So what you want to do it inside? You want to pour more metal in that, or you want to go only that the structural surface or a structural support is more than enough for that. So that we have to choose here. No, that will be reducing that timing of the printing, as well as that quality, durable, everything will be improved, and the material wastage will be very much reduced, and we can use for different parts also. And enabling quick of prototype product and product to market. That is nowadays it's coming. No, whatever you want, you can just print out and we can use it directly. No need of waiting all the such things which is used in no traditional way of manufacturing. That will be 50% less energy consumption that subtractive manufacturing. What we are saying that legacy type is a subtractive manufacturing. It will not remove it, will not immediately, we can't change that. No, it is started, it keep on going, then it will come stage. Now the lag is for a mass production only. That output and all, we have a different type of printers are available. Even metal also we can do. But the problem is that it is going for a manufacturing in a vast level or a mass manufacturing, then there is a question mark. That will be a lag in that. So some of the object which is we don't use the mass manufacturing. We want something. Sir told me that, Mr. Tiraj sir told me that, I told that they're using for this one, right? Aeronautical space research and all. In that case, we don't go for a mass production in that. In that, what the particular want, we just make a 3D printing in the same. We don't go for a mass production for that. In that case, 3D printing will be very much useful. And the core concept, create a 3D dimensional object. We can use such a various tools that CATIA, SolidWorks, NX. There is a vast tools are available, but that is not familiar tools. Not only the basic tools that are all used. That the company is from German company and French company, so they are very good companies. They are using that. The same company, the vast user of world over, they are using this, so that the user is there. But now it will be converting the people will pulling to 3D printing. So that is what the next revolution or a next generation will be seen in this. So the layer by layer until that object is print. So this is a concept, you have to go through that. I think in your university also you have the 3D printers and all. How we can utilize it in a different way? And you have to understand what we are having is maybe that limited edition. What is in a current trend? That also we should know, so that we can we can talk to the students and we can convey what we learn or what we understand about the 3D printings. So you just convey that, because the company is asking what you learned from only the colleges, what you know apart from that. So if you're going for an interview in 3D printing, they'll be asking what is the machines which are using in that, and what are the tools they are using in this. So, and what are the companies they are using. So there's a kind of question. They just want to know how aware of that, what you're coming for the interview. Okay. And the core concept is same, that layer by layer, this is a concept, how they're printing. You can able to see that flower vase will look very complex. If you want to do in a normal subtractive manufacturing, you have to design the part according, you have to design the mold for this, right? You think about this is not easy. It's a very complex shape, how to do design in this. So we need a very experienced person to for a programming language. But nothing, you can 10th boy, if you know that tool 30s Max or SketchUp, whatever they do, you can directly go for a print. No need of spending time and money for this. A simple that the GIF file is more understandable. You can see the complex of the shape. If you think through that manufacturing, normal type of manufacturing, it will take too much of time and effort. And I want to see the prototype. Then you can't spend that much of money for that also. So I hope you understand, right? The powerful of a 3D modeling and additive manufacturing. Both together it works. Okay, these are three types. Whatever we are talking now, we just understand that. There's a formative that we know, that injection, blow molding, casting, that and all come under the formative. Subtractive is what we are doing in this traditional. We are removing the material from that mass object. So there is the workpiece, what we say, no? We have to get a job or workpiece. We have to remove from that circular cylindrical object or a box type object. So we are just removing the material. So there is a material may still huge. And additive manufacturing, it's what the trend, what we want precisely, we are generating or creating that model or a prototype or real-time models. So these are three different stages. We are in the stage of additive manufacturing. We can't change it, all those things, but the trend is changing to additive manufacturing. And this is a material. So what is a subtractive and additive manufacturing? The material for a subtract manufacturing, this is a material. And if I want to get this type of output, the wastage will be huge because we have to remove all the materials and all. Then whatever we can get the output, but material waste will be huge. Think about one, if you go for a mass, then it will be more, right? And the same thing, if you go for additive manufacturing, we are just pouring the material and it will be melted accordingly. Then where you want exactly, it will be added on it. The wastage will be very much less because there will be brim and the structural support for the sides and all, right? That we have to remove it. So that will be, the wastage will be very much minimal. So this is the two images can understand more about that, what is additive and what is a subtractive manufacturing, how we are using in a traditional way. And yeah, this is a revolution. You can able to see that industries, so what the hierarchy, what are the people we already talk about this. Now you can see that field and how they are using. Then this video makes sense for all that what will happen in a day-to-day life. It will be keep on upgrading day by day. in a different type and different ideas. Please have a look of this.
The assembly line, providing a significant reduction in the cost of components, eventually leading to applied innovation. Even more so, we would be able to reduce industrial waste, try more experimental designs, produce finished products much faster, and create highly customizable products. Restaurants would be able to 3D print dishes that are not just based on your preferences, but on your specific biologic making. You would see it used in the acceleration of space programs in with additive manufacturing becoming a key component to the future construction of our space colonies. Doctors would be able to print custom-made prosthetics and organs after infusion. Clothing stores would allow you to order designs completely from the convenience of your home. This future is not too far off. How do you think 3D printing will impact your future? And do you think 3D printing's impact matches its height?
Yes, so that you can able to understand that no field where they are used. So almost all you can able to use it in this, and not only the mechanical sectors or automotive sectors. You can able to see. I'm not going to run a full entire video. You can able to see. We can able to print an entire building in a 3D printer. It's a huge printer actually. Okay, so I hope you can understand, right? So you can able to do in a engineering sector of a civil and also an architecture side also. Hope you understand till now, right? So till now, any queries from your side, so that if you want to ask any questions, so let to go to few more slides. Before that, I just want to know if you want any ask the questions regarding this. Now you can get a clear idea, right? So what is a 3D printing and where they are using, and where the industries they are using in that. And whatever is shown is a very few. It's a vast industry they are using a 3D printers. You have any questions or query?
Sir, can we use this technology for baking industry, particularly because, but practically has it been used, because we find a few, is there any example that you can give, around Chennai or somewhere where any bakery which use 3D printing technology for making cake, cookies or cakes or different wedding cakes or something kind of that?
Actually, sir, we are in Chennai. I didn't aware of that. At Bangalore, the companies are doing. I'm not sure about that, sir. But they are doing that industry of pastry department also. They are using as a 3D printing, and the burger and the patties are generated by 3D printing. I'm not sure about which company is doing. But anyway, if I have a real answer, then I can, because I can't give this as a company. They are simply I can't say. If you have very solid proof only, I can able to say, sir. But they are doing. So what they are, I saw that many YouTube videos and all, they are using that, because I need to update myself what is in a 3D they are doing and all. So they are showing in abroad, they are showing that, but India they are not showing. Till now, I didn't see any companies. I heard about that. There's a Bangalore-based company. They are doing that.
And normal polymers, we have, standard plastics, which has been used.
Yes, sir.
Like that, any machinery specifically available for bakeries kind of thing or pastry manufacturing?
Yes, should be, sir, actually, but I'm
Okay.
not sure about that, sir.
Okay.
Correct,
Okay.
sir. Because anyway, the concept is same, that layer by layer, but the type of machine, because these nozzles are very tiny, so 0.3, 0.03 like that. So because of the detail what we need, that way the point of the needle will be very, very tiny. But if you go for a vast like pastries or cakes or bakes and all, if it is go for smaller one, that will take time. So that we need a very good size for that. So it will be differ, definitely.
Yeah, because people use it for 3D printing for building houses.
Yes,
Like
sir. Yes.
a lot of you could see. That's why there naturally the nozzle will be naturally bigger.
Yes, sir.
Outlet will be a bigger one. Like that, if
Yes,
you
sir.
could have some machineries, then it will be definitely a breakthrough in our baking industry, correct?
Yes, sir. Yes, sir.
Because
yes, sir.
like the people who create the bakeries and wedding cake kind of thing, they spend a lot of time, maybe 3-4 days to manufacture one cake.
Yes, sir.
Oh, yeah. Okay.
Yes, sir. So actually, there is a pros and cons for every field. If you go for a technology, and now the AI also implemented, they know that's a revolution of equal to 3D printing. It will be AI. It's not only for one. It will be go for all that industry. The impact. And anyway, AI is totally different. So the people thinking it will be reducing that human working culture and all. It's not reducing the human person in a company. They'll be increasing the productivity using of AI, not reducing the people. The people are very scared about the AI because they will be reducing the people, because AI is doing everything. So it's not like that. They're increasing the productivity using of AI. Okay.
Thank you, sir. There are a few questions,
Yes, sir.
like will it be cost effective soon, sir, irrespective of the field of application? There
Yes,
is a
sir.
question which has been put forth.
Yes, sir. Yes, sir. Right, sir. Sir, it's actually it started 10. What I'm hearing this 3D printing is a 10 years back, sir. At that time, one machine will be very huge, more than 1 lakh. Now you can get a 15,000 to 18,000 same kind of machine. If you have a genuine or branded machines, it will go for only 30,000 to 35,000. Depends upon the detail how you are getting. So it will be much reduced. If again it will going for mass production of the same 3D printing, then it will be very much reduced. And what you're using, that also important. You want a normal PLA, or if you go for a metal or anything, that depends. It will be cost will be range will be changing, and the cost will be very much reduced. And in further, it will be very much reduced also, because if it is a mass production, we can now one of my student is he is assembling that 3D printing and selling. So, but we can't go for the large scale because we don't have any certification or anything. He just giving that students or over the friends and all. He just doing itself. They'll be going for 18 to 20,000 rupees only. So whatever that whatever the needs for the 3D printer, they just get it from that Amazon and that Juba and all, and they just assemble and selling that. So it's like that. So that will be easy to print, easy to assemble that printer also. It's not a big deal.
Thank you very much, sir. Mr. Vishnu Vardhanan Vardhanan, participant, Mr. Vishnu Vardhanan.
Yeah.
Please, you can go ahead with your question, sir. Mr.
No,
Vishnu.
actually, it's not a question, sir. Actually, the answer for the previous question that he asked about the printing of baking products in that one. And for your kind information, the people are now working with that 3D printing for food actually.
Yes.
So,
Yes, sir.
like he told, the machines are available for baking the cakes or any other things, sir. Actually,
Yes,
one of
sir.
my friends from IIT Delhi is working in the expertly way of food printing and everything, sir. So the machine is available, sir. Actually.
Okay. Okay. Thank you for the information, sir.
Thank you. Yeah.
Sir,
Thank you so much. Yeah. Yes, sir.
Light into this, like what type of like the polymer what we use here, like that, see, we need a cream with what do you call sugar powder and egg and ghee, like normally what is being made, no, like that, any idea do you have, sir, on that manufacturing side? Mr. Viswanathan, sir, Vishnu Vardhan.
No,
Yeah.
actually, they are working, especially a lot of problems are occurring at the area of nozzle sector, sir, actually. So, like you told, a lot of materials are there mixing and everything. So, they are facing the problem in the nozzle. So, because of that rheological factors, they are working in that one, sir. But still not commercially available, sir. It is in the research mode only, sir, actually.
Oh, okay.
Yeah.
Yes, sir. Thank you, sir.
No, the white and the cream. Okay, certain time need to be, a lot of factors are there. Okay.
Yeah,
okay.
the factor is called rheological factor. That is the
Correct. Okay.
Thank you.
Thank you so much for your information. Thank you.
Thank you, sir. Thank you so much. And we can see that additive and subtractive manufacturing. So we can see that procedures of what we do in manufacturing of additive and subtractive. And
Sir, it seems our Dean ENT Etraj sir has got some question. He has raised.
Yes, sir.
Not question for Jaisalan sir, Dr. Jaisalan sir.
Yes, sir.
Actually, there are machines available for bakery as well as for the food. Okay, like potato smashing, all those things fed into the machine, and it will be making the nuggets like that. So it is available, but the only thing is, as he said, it is whether it is used in India or not. It's a question.
Thank you, sir. Thank you,
sir.
Probably, I think, if somebody can take up this as a very big research work, because a lot of potential is there in this area.
Because a lot of different types of cakes, shapes of cakes. See, for example, I'll tell you, yesterday I went to a hotel and they made a panda dosa. What they are doing is they are making a dosa and then cutting it into the shape of the panda. So instead of doing that, you are wasting the dosa material, right? So instead of that, if you print it by 3D printing, it will come exactly. And without any waste of material.
Yes. So that's the advantage of 3D printing.
Yeah.
Thank you, sir. Thank you so much. Okay. So this and all we already know. Anyway, in the next slides, we'll be showcasing one by one of this. And see, it's the evolution of 3D printing. It starts from 84. Here we can see the birth of 3D printing. But I start to know only the 10 years back only. So it will be like a printing, then it is a patterned. Then 88, the technology was available to public. Okay, so now normally if you go for any type of higher level of technology, they will be implemented in the defense sector first. Then only it will normally come to that civilians. It depends upon if you want to go through the civilian purpose, or it will be stay in the same as a military purposes. And nearly 8 years later, then 3D printer was first used, and you can able to see the first self print was developed, 3D print was developed, and manufactured based on the necessities. Now we have a data 2014. Now we are 2024. So we have very good revolution in this. Very good revolution in this 3D printing. So actually, see, it start from 1984 itself. Same like that, all the technologies or the softwares, like CATIA software, NX, all the softwares previously used in the defense, and even the internet also, right? You people are well aware of that. So once it is going to establish now, then it will go for the civilian version. Okay, though, so this is what not only we are speaking about only the few from the healthcare construction. So what we chat about this or discuss about the food industries and bioprinting. Yeah, I have a very good presentation we got from Hyderabad. The company is doing for all that, even the heart and kidney and all, they are doing in a 3D printing, but it's not for a human. They are using in a mouse level, mice and all. So they showcase that printers what we are doing on that, and they sells the print, no, their cells should not dead, like that. Their high level of criteria on that. So soon, if it is like that, then there is a very breakthrough in that. Even though food the same like that, biometric also very important, because kidney transplantation and heart and all. If we can able to do it in a printer, then it's cost effective and then the life saving also. So anyway, this should become first in my perspective. And so fashion architect already they are doing well in that. Then jewel industries and replacement. There is almost all the industries they are not touched with that 3D printers. So that in the mainly they're concentrating on the user end part. So all the parts which you want to go for immediately, you can't do it, or no, you don't have any spares on it, because whatever we are manufacturing today 2024, after 2 years we can't get the parts. That is a very difficult for changing and all. Then we have to adapt. We have to go for other new product or a new vehicle like that. So that if you have a printer, then we can go for a 3D scan in this, then we can generate, and as a model we can go for a 3D printer and go for a jewel design. There's a high level of expending of money in the jewel design, and aerospace, automotive, and that construction, AEC, architecture, construction and engineering companies, they are using that. Now they are full-fledged, they are using on this 3D printers. Aerospace, I'm not much aware, because it's not easy to, because you have to pass that cryogenic level and all. So it's a very vast in that. But anyway, though, so if it started, then it will be go for the next level, right? And workflow. So how we do that? So we start from the concept model, then we can go for building a 3D model using our softwares. Concept model, normally what we are teaching till now is a paper with pencil. Then once the developed, then we go for a clay, then it will go for the next level. Next level only we go for a 3D modeling. Anyway, this for that only for the slide presentation, I go for that. Once it's go with 3D model is done, then what you have to do, we go convert into STL file format. Once STL is okay, then it go for printing. STL is a neutral file format. You can convert it to neutral file. There is a many tools are there. It's a free version only. It's not a paid one, and which is supposed for the 3D printers. Once 3D printing is over, then it go for post processing, because you want to make a coloring and all, and buffing, and there are so many processes to make it aesthetic look. Then once it's okay, then painting and go for assemble, then it's go for a output. So if you go for the same thing, it's a manufacturing traditional way. There is a lengthy process. The cost is too much heavy also. But if you think about that mass production, then it's okay. At present, I can say, but it's otherwise it will be more than easy with using with the 3D printing. Only concept modeling, HTML file is not that much of a big deal in that. You can do it in a 3D printing directly. We can go for just spend the time how to go for a structural support and brims and all. Then we can go for 3D printing. Only 3 steps, the simple step. This too is very important. Concept, once concept is okay, then go for a modeling. If it is a very huge in size or whatever, we can go for a clay model. And once clay model is okay, then we can scan it and we can get it output, because what they are using in a real-time project also. So here the selectable suitable printer. As per the printer, we have to make a slice, right? We have a slicers. So we have to, slicer means the tool which is convert into STL file to 3D printing file. And that is a slicing into layer by layer, then which produce the G code. Then we go for a 3D printing. We can able to print directly through a system, or we can have a pen drive, or we can have a SD card. We can do the same. So this is a normal workflow what we do in a 3D printers. And the file format which is used for a 3D printer, the STL file and OBJ wave file, the ZBrush, ZOG, GOZ, IGS file and binary 3ds Max files. So these are the files you can able to print. Print when you can convert to STL file format. Some of the printers directly it will take all those things. Depends upon the printer. You have to convert it. There is no big issue in this. In what other software you're using, no, there is a export option. Definitely STL OBJ will be available and IGS will be available. This is a different file format. Max and all. That is a full-fledged, you can do it there itself. It's a very complex model also, we can able to do it in a 3ds Max, which is used in the cinema industry and Maya. Autodesk Maya also for a character modeling. So whatever you want to do as a character or object, we can do it. In this and all, we can normally 3D modeling and all, we can go for a manufacturing or product design. But this options, ZBrush, 3ds Max and studio files, that and all, we can go for a character Maya, that and all for a character modeling. So that will be more touch with the cinema industries. So blasting of bridges, building and all. Actually, they are very prototype. They do and make a setup and do explosion and all, then they do it. And thumb rule. Polygon only convert implied geometry of respectively polygon, because it will what your the nozzle, no, it will become like a polygon type or a triangular type. Turn off smooth shading while modeling. So if you have any smooth, no, you have to, because it will not generate the smoother surface. Note bitmap images. Bitmap means if your image is added in the particular model, that images will not adapt in this. Then closed geometry. So that is important, because once we convert as a closed geometry only, that prototype, I mean, the 3D will be converting. So you have to convert as a closed geometry. An appropriate amount of geometry, balance between unmanageable file size and well-defined to smooth and curvy geometry. If it is too much of smooth, we can do, but depends upon the system. It's not a system. Depends upon that machine what you're having. From that, we can go for a more detail. Otherwise, the detail will not get. We print actually Einstein's on small image. We got it from STL file. We make it. When you see from outside, it will be like a 2-3 inch, only 3-inch model. It will take actually 4 hours. But when you see a little bit away from your eyes, 1 meter, 2 meter, it look good. 1 meter length is okay, but if you come closer, then you can see that no lines will be moving along that. So why? Because that detail of the nozzle of what we have a 3D printer is bigger than that. It's not suitable for that sculpt design for a smaller level. If it is a smaller nozzle, then it's okay. So it depends upon that what you have, no, that machine, they can get a very good output. And the scale factor, that also important. So suppose we just create one drone actually. We design and we do a drone, but drone is very big in size as per the design. If you scale down as per our design should not scale, then only we can get all the detail. So what we do, we don't have that much of big 3D printer. So what we do, we just sliced in a different way as assembled component. We printed each and every one and separately, and we make the assembled later. So that's a way you have to think, because don't think we can able to do it a separate part, and we can go for assembly. So normal assembly like thing, you can go for that. And structural integrated. So integrity means the same thing. Don't go for too much of metal to waste in that. We have to think whether that material will be added inside or not. Definitely, if you want to, because it will be more flexible, or maybe brittleness will be there. So we have to go for a structural support that also available in 3D printing. What type of structural material you want to place it inside, or if it is going to add more load in that, then according to that we have to go for the structural frame we have to design. Now trend is that manufacturing reducing of material, you have to go for that type of structural. Normally honeycomb and all we used to go for strengthening and removing that, I mean reducing the material. STL reason for occurrence, defining for error and understanding of error. So why we go for this and all STL file format, you have to understand that, because once you slice, the slicer will be prompting this is not, you're not able to do it. This is a very difficult to do like that. The reason will be occur through through that software. So what you have to do, and where is this exact support you have to do? So think about that as a slanting object is there. How we print that? Because the melted plastics or whatever, that will be pour in a certain direction. But if it is a little bit angle, then what you do? Either we can support as horizontal manner, we can print. You understand, right? Think about that tail of a aircraft. So that you can see that will be a little bit slanting and tapered. So if you want to print like that, it's not easy because that no, we don't have a structural support. In that type, what we do. So that and all, the software itself nowadays, no, what we have a software, we are using the Cura for that software called Cura. In that they will be showing this or the support you have to mandatory to create a support for that to stay the particular 3D printing in the some height. So that's a very interesting fact when you're using the STL file. So here we can see what I said, na Cura, Prusa, Slicer, Cura, and there is a repeater as well there. Right, you just take a screenshot. If it is a free software only, you just generate 3D model and just put it inside. You can able to see, just there is only few options are available. Cura having a more options. When you go for Prusa, it's a very easy to understand what is the 3D print, how they're working. They can understand the printer, how the printer is working or software is working. Once when you go for printer, it's a different because we have to set to that table, base table, and that movement of that object, 0 level, that the plate is in a perfect no horizontal or little bit sliding or whatever. And sometimes you can't remove after printing. That also one problem we'll be facing. We will not remove from the plate of the base plate. Then what we do? So you can see, no, this is not too flimsy. If it is stick with the bottom in the bottom, if you pull this, what will happen? The feathers will come out. So what we do, as a practical knowledge, we go for the glue gum, normal gum, right? The Fevistick gum. We used to put it on this plate and make a print so that it will easy to come out. But initially it will be tightened because of a hot material. After that, no, simply you can remove that, it will come out. Otherwise, no, it will be stick on the board. So that's what we are getting the practical challenges so that we have a solutions from the different company. They have a different solutions. So these are the solution what we got. So please take a screenshot, Prusa slicer or a Cura. Curas. So this is what converting it to STL file to Cura. Cura what will do? This 3D model is sliced into different layers. Right? How many layers? Because of a printer layer by layer, how many layers you want to print? So it will not take much time. It will slice immediately. Once slicer is over, then that you can generate a G code or M code, G code. That code you have to copy and insert into that slot, which is for a pen drive or whatever is there, depends upon the machine. Then you can take a printout, but the printing time will be increased. You can see, what I said, that this feather or leaf, it will be little bit turned out innerward. So how to print like this? Right. So when you see like this, okay, fine, good. But when you ask a print, when you go for printer, how to print like this? If it is say it is slanting outside, something is slanting inside, how to make a print? So that we have to think. That is the only the factor you have to think as a human. You have to think and give. Okay, this is the right way you can give. So we have to give that structural support for that. All that leaves. That will you can just pull it out because that's a very thin layer. So you can easily pull it out. So this is only the practical challenges what we are facing when you go for 3D printing. And STL file errors, so conversion issues, converting to parametric design to triangle based design. So we have to convert as a triangle based design and no equipped enough, bad design or a 3D printing, bad junction of faces, result for a 3D scan. So these are when you go for a 3D printing, we generate from the reverse engineering. So we used to go for a scanner and get it output so that if it is not properly closed with that, no mesh files will be coming, right? If it is not properly closed, that also we'll be facing at in a 3D printing. And when you slice, immediately it will show the error message. It's not a closed, it's not suitable for a 3D printing. So that and all we can able to check with us the 3D printers. Anyway, I know this is a overdump in a single class, but I'm just giving the awareness of what we do in a 3D printer, what the behavior of a 3D printers. And invert normal, if you have any bad edges or a shelled component, overlapping triangle, intersection triangle, this is all the problem we are getting errors when you go for a print. Right, everything what is STL file, what you are getting from the STL file to convert as a slicers. Okay, this is what the triangle, this is what the triangle. When the print, it will be printing like a triangular manner. If it is in a flip or normal, if it is a reverse direction, then it will be like a error. So normally it will not come error if you model in a proper way. If it is you're going to twist the object in a different way, normally we used to go for a 3D model. We used to twist and get a very solid to very complex surfaces. And that case only we have a problem with that. But 3D printer have a capability to create any type of model. But if it is a true model, then it's okay for that. So this is what a triangle they are saying that. So this is what a nearly bad or bad contour hole. If you have a hole, this is what I explained, right? If it is a gap, then normally when you go for a scanned printed, scanned model, we can get this type of problem in this. Okay, same like that shelled. Shelled means object is full solid look like, but it's if you cut and see, there will be a shelled component. If it is fully shelled, then what happen when you go for printer? It will not print, right? It will, because it try to only go for outer only, that top portion. When you go for a top portion, what will happen? Nothing. Again, it will be pouring inside. It will take too much of time. Then you have to structure support from start from the bottom to, you have to give the proper way how to do printing in the solid thing. If it is want in a hollow or a solid. Okay. So this is what an intersection. If it is an intersection object, again, you have a problem with that. So that is what a noise cell. Shelling inside the smaller part, that will be the inner portion, intersection portion will be creating the problem in that. And now you can understand this. Here you can print up to this level. This is what the triangular box is there, right? The box out, your box will be printing in this level immediately. There is no gap over, no, from here is the totally there is a gap is there. Immediately it will not come up printing. So that here it will come the brim and it will be come up to the structural support. After that, it will be strong printing. From bottom to the top, this level, the object level, that will be a structural support. After that, it will go for the normal printing. So this is what you have to instruction to the part. Okay. Overlapping triangles. This is a core theory actually. So when you go for a 3D printing, so you can understand what will happen in this. So overlapping of, you can see, no, this is not a proper or a true triangle. So it is an overlap or no, it is a crucial object, then it will not go for a 3D printing. So the smoothness will be not available. Same intersection surfaces. So this is what we are seeing now. Invert normal, shell, overlapping triangle, intersection triangle. These are the errors which able to see when you go for a 3D printing. Before 3D printing itself, you can understand what is happening in that. We have a solution for that. But whatever you want, you print. That also an option is there. Whatever happen, you print. Then you can see it is taking off a 4 to 6 hours. Then you can get the not getting a proper output. That will be difficult, right? If you were a testing purpose or if you're going for not learning period, it's okay, but it's go for a commercial use, then it will be difficult because the time is a constraint. We have to do it better and faster. Anyway, so whatever we do, we have to do practice on that, then we can go for that. So there is in a printing technology, there is options, so direct energy deposit, light photo polymerization, material extrusion, and powder bed fusion, sheet lamination, binder jetting, and material jetting. So these are the type. We have a 3D printer itself. There is a many types are there in a different form. I just go through that so that you can get a clear idea of that. So I just not running an entire one, so it will take time also. Here we can see the direct energy deposit. What will happen in this? There is no audio on that. Just mention this name in this. So this is what a slicer, the level by level. It's a layer by layer welding type. So that's a EBDM. So which is used in that vast areas. Okay, so this is what the first direction, you can understand this, right? And the same like a laser powder forming. This and all come under the additive manufacturing, not only the 3D printers, what we see, no? This is a kind of 3D printers. So let's go for what's the last print, right? So this is the output directly. This is a LPF, so laser powered powder forming. And there's a digital light processing, DLP. So in this, we can go for a very complex shape also. So it's interesting, right? DLP. Then SLE, lithographic. This looks like some science fiction movie, but it's not real. So this is additive manufacturing all. You can see this supports brim. So this is what actual object. This is what actual object, but you can see this on the support, right? What I said. If it is hanging outside, then how to make a print? So this is what a structural support. And this is a level. So you can go for different post-processing, then you can get a final output like this. And it's not a prototype. This is a working model, or we can go for directly, we can in place where we go to utilize this. Okay. And fused deposit. the material extrude is normally what we are saying. We know well about this. FDM, right? This will come under the FDM. And metal laser. DMLS. The using of metals. And same like that, there is a beam melting is there. That also kind of same, but we don't have a proper video for that. And then SHS. This also come under the powder bed fusion. And this one using normally all the car companies, they are using this. I'm just introducing the type of printers in a different variant type and variant usage also. Whatever we are seeing, the traditional is different.
This makes it amazing to see. The laser director's feature scan system, which consists of a nerve control system. During printing, the mounted powder supports the silicon parts, which eliminates the dedicated simple instructions. Once the printing process is complete, the build chambers are down to ensure optimal mechanical tolerances and performance. The finished parts are removed from the build chamber, separated from any excess cabinets from the other. SLS printing units can be made, if necessary, they can be post-processed to be smooth and immediate.
Okay, a few more to go. This is SLM. Okay, good. LOM. This has come for the sheet lamination. Good. So on a few more to go. So it's a UAM, ultrasonic additive manufacturing. So this is a kind of welding process. So it's like embossed in a sheet metal directly. Good. This also comes as a sheet lamination.
The chemical 3D printing process, powder binder jetting. The 3D printing process runs on all available voxel jet printing systems with a variety of different particle materials such as sand, plastics, or freely selectable powder materials. The only requirement is CAD data of the part. The process starts with the application of the loose particle material to the building platform by a recoater. Afterwards, the printer head applies the binder selectively at the areas where the future part is to be reduced, thus connecting the layers. After the binder has been applied, the building platform is lowered by the layer thickness. This process is repeated until the part is completely finished. The unprinted particle material is removed after the printing process. The models can be used directly for metal casting or as design and function models without time-consuming post-processing. Find out how VoxelJet can optimize your production.
Okay. And normally what they show in this, no, for horizontal manner, it's not easy to print in normal type of printing. What we do, we go for a vertical and make a print. With horizontal, we can't get that tangency properly. So different printers have different idea. So this come under the material jetting. So conclusion, what are that almost end of this session. So the type of material which is used in that, so ABS plastics, why we are using ABS? So that is a strong and durable, impact resistant and structural strength. And the temperature will be 220 by 240. Here the temperature, bed temperature. So this is very important in this. Why? Because now whatever where the filament you are going to insert in the 3D printer, this is what you have to maintain the degree to melt that particular material. And the bed temperature should be, why bed is nothing that bottom surface, right? That a glass, or it may be, normally it will be glass only, or any kind of material or metal part. So if it is that, you have to maintain this temperature for the bed, otherwise the bed will getting cool, so that no, that what are the printing, no, that will be settled out in that glass or wherever they print. This is very important. Whatever that material going to use, no, we should know that that temperature. How we know the temperature of the object or that filament. So each and every filament having, it's coming with a roll. In that roll, we can able to see the color and the manufacturer and the temperature, the bed temperature also. They will be mentioned clearly in that, and how long you can able to use. So that also important, because once if you open that filament, it should be, you have to use it within that lifetime period. That the time period is there. Whatever they mention the life period when the package is not open, because we are facing that kind of challenges. Because if you're not printing for 1 month, again if you go for a print using the same thing, it won't print properly. Because no, the filament's getting and more like brittleness will be there. It will not, if it pulling that nozzle to that pulling the direction, automatically go for a braking, because it will be go through nozzle and the fender and all. So there is a chance of breaking and it will not properly melt. But if you take no that box, it will be shown, it will be go for a 2026. But what we purchase, it will be not using for a 2 months with when opened, right? I'm not saying that if it is a close, okay, fine, you can go for what the time period what they mentioned in that. But if you open, it will not go for that much, because you have to print it as soon as possible. Otherwise, you can't get that flexibility what they mentioned in that. And the colors, the different color type of colors are available in ABS. Same, we can go for a PLE, and there is a properties of a PLE. The temperature is 190 by 220. What are the colors you can able to get it in this? And you can go for a more detail in this. You can see the line of sculpture is there, right? That you can able to create a using of a PLA. And we go for a PA. And here also you mentioned that temperature, and these are the material which is used in that commonly using materials in 3D printers. And it should be storage in what, and total water dissolved in cold and warm water. So because you can see that the brims and all, no, but if you're using that high level of flexibility or easy to use, then that material will be costing more. So you can just put into the glass water, so automatically it will be moved. That will be very easy for us, because it's very difficult to remove that structural surface of a plastics in that. So that is interesting in this. And this is a part of a 3D printer. That's it. Only the frame cover filament is what was so filament in this corner. They will be mentioning each and every specification of that particular filament. It is packed with one plastic paper. So if you remove that, then what I said, no, you have to maintain that. And this is the extruder, then it will become like this. It will come to the extruder. It will go to the nozzle, and the nozzle is this one. This will be too much heat according to what we fixed. This hot end, the cooler fan will be there, same like our CPU. And printer display, this is a coordinate will be running over here. Maybe here you can allow to put directly, you can go from laptop, or we can go for a pen drive, whatever. And this is the bed, what you said, no? This is the bed, and bed temperature you have to maintain. So otherwise, no, it will come out. After one by one printing, no, it will have too much heat also, it will be come out. So that will be moderated what they mentioned in that specification. So this is a simple, whatever the printer will take, no, not normal type of printers, this will be there. And the parts of a print, what are the object in a 3D print? The bottom layer, and there's the outer shell of object, and infill. This is what a structural support of the object, or a part or a component, and the top layer. So this is the thing you have to keep in mind, what to wear, how much material you have to use it. Then I show you now the Cura Prusa under the software, it will be automatically generate what to do inside and all. But we want to change, we can go, there is option to change it accordingly. Okay, so this is a raft, you can see the boundary, and there's a brim. This is for a structural support. Before starting, it will be brim will be created, because from that it is going to start a 3D printing. But after that will be remove this. This is for a base structural support. Okay, that's a so this bit lengthy, but not only your say only the printers. There are the different type of printers, how they working and all. Yeah, I know that, as I'm a teacher, same like you. It's a single presentation. If you go too much of information, that will be overdump. But this whatever you understand, you just keep it in your mind, and do at least one type of 3D printing as a full process. That will take only 1 hour. 3D model, you just take 3D SolidWorks or whatever. You do just a rectangle, extrude, that's enough. Go to the Cura or a Prusa, slice and print. That's all. Then we can get the confident. Then you can go through all the printer types and everything. That will more easy and understandable. Thank you so much. If you have any query, please let me know.
Thank you very much, sir. I would like to, if any participants who want to ask questions, although it is there, you can also unmute or ask. You can chat also. You can give your questions in chat. One of the questions in the chat is: will it be cost effective soon, sir? Irrespective of
Yeah, I explained already.
Yes.
Now, yeah, it's the cost effective only. You can go for different type of printers. I can able to show some of that. The people asking you are, you're choosing different type of company. Why showing the company name and also that's why I'm avoiding to show that. There's a lot of printers are available.
Any other questions? Sir, though amazingly wonderful the products through which you can take us, what you feel as a threat to this technology, both ethically and scientifically?
So this, now you can go for AI also, sir. We know that we are just changing to the next revolution. We are not. You have to touch with that because you are in a legacy of what the manufacturing are currently using. We are not. You have to adapt to what is there. Otherwise, we can't stay in in a race. What is that in advanced technology? We have to adapt that. Same like the AI also. They also as a revolution, same like the 3D printing also, it will go for a revolution. That will be reducing our human work and increasing their productivity. So that is what you have to, what are that going to having that implemented as a new technology, we have to adapt that. Otherwise, we will be in a lag. We will not run in a society. So that is what we know, right? As a mobile phone, we see that a revolution in that. Same like that, now it will come to AI to 3D printing also and adapt the future.
Any other questions from the attendees, participants? Can unmute and you can ask questions. Anyone from the participants? Can raise your hand. If you can, there is a hand feature is there. You can raise your hand. I will unmute you. In Q&A. It's a question and answer. What about metal 3D printing?
Yes, sir. Yes, sir.
Yeah, this is one question by
Yeah,
Sri
metal,
Varshan. Yeah.
nothing, sir. Metal is using the instead of a PLA material, we go for a metal. And there is a different type of printers for that. What I showed the last few videos and all, right? So because normal, we can't go for a 3D metal printing because it's liquid, right? And too much of hot also, and weightage is also there. For that, we go for a different type of materials change to metal. That's it. Instead of PLA, we go for a metal. That's it.
Okay, sir. Thank you very much, sir. Any other questions from the participants? I think I don't find any more questions. Participants, there will be feedback link will be shared in the chat. It's a very mandatory that all of you fill it, sir. Fill it. I think there is no more questions, sir. It's been a wonderful experience, sir. I take time out from your busy schedule, sir, and come forward and give us your expertise on 3D printing, sir. Again, Mohan, sir.
Yes, sir. Yes, sir. So thank you, sir. Thank you so much, sir, and arranging this session to you through that M.G.R. University and coordinator, Mr. Vijay Kumar and Rajan, sir. So thank you so much for this opportunity, sir.
Thank you, sir. Thank you, sir.
Thank you.
Thank you very much, sir.
Thank you, sir.
Thank you. Dear participants, the attendance and feedback link for day one is shared in the chat box. Kindly, it's compulsory to fill it up today itself. And that concludes the first day session. So tomorrow morning, same time, I expect all the participants to log in. And the resource person for tomorrow will be Mr. Praveen Pandian. Managing Director or CEO, Evolve Robotic Lab. So with this, we can conclude. Thank you very much. 10 o'clock time, all of you should be logged in. Thank you very much.
Sir, the chat is seem to be disabled, sir. Sir?
So you're asking me, sir?
Sir, thing is that the chat is being seems to be disabled, sir.
No, I didn't do anything in this. I don't know, first of all, how to disable this.
No, not
Oh.
you, sir. Because we are unable to ping.
Okay.